The numbers are moving up? Excellent. All right, so welcome to Math341. This is probability. This is the first lecture. All the lectures are going to be recorded and posted online. For the most part, if you speak in class, the recording will not be able to hear you because that's what this green light on me is for. So this is where the microphone is. Okay? If I'm not repeating a question, just remind me to repeat it. I know a lot of you are going to be doing interviews, you're going to be traveling and whatnot, so this is a great way to see the lectures that you've missed. When you speak up in class, if you make a great comment, I will remember that. Please send me an email and I will add it to my grade sheet so that when I write letters of recommendation for you, if you ever need something like that, I can be specific. The more specific I am, the more powerful the letters of recommendation are. If you say something bad or stupid in the class, I have a very bad memory. I will not remember it at all. I'm very sleep deprived. Don't worry about it. Just send me comments every day when you do something well. Okay? Hello. The point is, this is a great opportunity for you to help me get to know you. So I'm a little bit different than a lot of professors. I have not been looking at the sheets of who's in the class. I'm not trying to find out who you are. I want you to come to me and get to know me. We can have coffee, have lunch, just come by your office and chat. There's lots of different ways we can do this, but this is to prepare you for the real world. When you go to the real world, you are going to be surrounded by people who are extremely busy. And if they are extremely busy, the last thing they want to do always is to get to know people. You gave your stuff to somebody? Hopefully this is good. Oh, wow. Oh, that was terrible. I should have taken the extra time to thought it better. Oh well. So shoot me an email. This is a great way for me to get to know you if you make comments in class. Okay. So introduction and objectives. Not surprisingly, the objective is to learn probability. This is a vast subject, lots of different applications. One of the difficulties is always, what do we want to cover? I like to start off by doing some stuff on basic combinatorics. We do actually enough combinatorics that people who go to Budapest can actually place out of the first class there. So there's a lot of really good discrete problems that come from that subject. It's also a great way to start seeing some proofs. So this is a mixed class in terms of the background that everybody has. We have people here who've already taken real analysis, who've already taken a proof-heavy class. There are other people who have not gone beyond linear algebra. You do not need more than linear algebra. But eventually, if you continue with the math or the stats major, which I hope you will get to proof-intense classes. So this class is going to be a little bit of a transition. So I will prove a lot of results. There will be some results that we will not be able to prove in a first course, but I'll motivate and I'll try to explain to you why they're true, or maybe show that they follow from a very reasonable assumption. You'll have some proofs on homework and on exams, but not at the same level as you would in real analysis. So this is a really good transition. This is, in my mind, one of the three most important classes you can take, and it's one of the reasons why I like to keep teaching this year after year. The others are statistics and computer science. And for those of you who've had multiple classes with me, I apologize. I always tell the same story now. I used to tell my students at Williams, if you take these three courses, you will always have a job when you graduate. You may not like your job, but you will have a job. I can no longer do this because a student at a school in New York did not get a job when she graduated, and she sued. Now what's great is with the freedom of information, you can actually download the lawsuit where she misspells words like tuition. And she has created a new level of discrimination that did not exist before, GPA discrimination. She claims that her 2.6 is just as good as someone else's 3.6, and the college does an undue amount of help for people with better GPAs. So I cannot guarantee you a job, nor can Williams College. This relieves me of any and all responsibility for employment. But I can say it is highly likely if you have these three courses, you will have a very useful set of skills. So I've already emailed you about 2 opportunities. I have a lot of Williams students who love this place. They love the students here. They are always excited to talk to you, to look at resumes, to discuss how you should apply for jobs. I'm happy to do mock interviews. And there's just lots of opportunities with these skill sets. Okay, so objectives. As I said, to learn probability. I want to emphasize the techniques and the importance of asking the right question. So a lot of work is actually figuring out what's the right thing to study. And once you know what to study, frequently you can give it to anybody with the same kind of training, and we all know how to do it from that point. But figuring out the right thing to ask, that's often very difficult. I'm no longer going to ask how many of you know about TED lectures. I'm going to assume by now most of you know what a TED Talk is. If not, I'll send a link later. How many of you have seen Malcolm Gladwell talk about spaghetti sauce? Excellent. one of the most exciting talks I've ever heard in my life. So it turns out that he asked a question that nobody else had asked in the history of serving spaghetti sauce needs of the American population. And it turns out that there was a huge segment of America whose spaghetti sauce needs were not being met as well as possible. And when this was discovered, a company was able to make hundreds of millions of dollars in profit. And again, it was from asking a question that no one had asked before. So I'll send you the link. It is worth watching. It's a great use of 17 minutes of your life. You want to ask the right questions. Now, once you ask the questions, you need the tools and techniques to be able to do something with it. That's what I can teach you here. I'll try to talk about how you come up with these questions. Why would we think of trying to prove it this way? All right, so we're going to talk about modeling problems and analyzing the problems. I've done a lot of applied mathematics. I've worked for the Internal Revenue Service, Major League franchises, finance things in Wall Street, a bunch of different places. The more complicated your model is, the more things you can incorporate, the better job it does describing the real world. What do you think the trade-off is? Yes? Your model is much harder to understand. How many of you are familiar with Galileo's experiment where he dropped two spheres from the tower to see does the mass affect how long it takes? Okay, several of you have heard of this. What were the color of the balls? So why don't we know the color of the balls? And it's not because there weren't any photographers back then and the portrait artist took too long. Why don't we know the color?
It's not important.
It's not important. Maybe if one ball was white, one ball was black, and they have different absorptions of heat, and they're being left outside for 6 hours on a very hot day, maybe one ball is significantly hotter, and if it's hotter as it's falling through the air, that could affect the flow. Maybe in some situation like that it could matter. But almost surely, if the balls were kept inside and they're coming out at the same temperature, the color's not going to matter. We don't have to include that in our model. Sometimes it's very nice and easy as to what you want to include and not include. Other times it's much harder. It's, what do I need to include so I have a good enough sense of what's going on, but not so much of a sense that it's overwhelming. My father got an MBA many years ago, and he had a class taught by a theorist who gave them an equation with 46 parameters to describe what the company should do. And my father was going part-time. He was working at the same time, and he goes, it's a beautiful equation, of course, love it. But I don't even know the value of these parameters for my own company, let alone for my competition. But it tells you exactly what to do. And so just because you have a formula doesn't mean it's a formula that you can use. Sometimes we will resort to Monte Carlo simulations and numerical exploration. And we'll do some discussions about that as to what do you do when you can't solve things in closed form. How do you get to a point where you can get a meaningful answer? We'll talk a little bit about elegant solutions versus brute force. So computers are significantly better now than when I was in college, which was much better than when my parents were in college. And what you can do with computers is phenomenal. You will all be required to do programming in this course. I don't care what you want to do. I am old enough that I've programmed in Fortran. If you want to do Fortran, we can talk. If you want to do one of these newfangled things that has like 3 letters and it runs everything, sure. I won't be able to help you too much with debugging. Okay, whatever you want to use is fine. A lot of people like to use R because R is freely available. For those of you who can't understand me, it's a letter after. Okay. The other thing is I like to use Mathematica. Why do you think I use Mathematica? It's what I used, yes. When I was an undergraduate, we had Mathematica in the computer lab, so I learned how to do Mathematica very well for physics labs. So I still use Mathematica, and this shows you the power of getting somebody as an initial customer. Is once you get them, there's a trade. There's an opportunity cost to move to something new. Now, I can frequently take the knowledge I've learned in Mathematica and apply it to other things. I do know C and a couple of other languages, but I'd like to use Mathematica. It's very friendly. It has a lot of functions already built in. We'll look at a lot of different equations and we'll try to get a sense of what the equation says without going into details. One of my favorite thesis presentations was from a student of mine, Jake Levinson, several years ago. He's at the University of Michigan now. And his opening slide is entirely filled with mathematics. And he says, we're trying to prove the left-hand side equals the right-hand side. And he says, okay, I realize that a lot of you are not number theorists. Let me expand out both sides to try to make it a little bit easier to follow. So it takes 20 pages to expand out the right-hand side of the equation. The 21st page is an equal sign and nothing else. And then you have another 20 pages expanding out the left-hand side of the equation. And I think it ends with the Spaceball quote, if you can read this, you don't need glasses. Okay? When you have something that is this long and this complicated, most of us mere mortals cannot look at 40 pages of mathematics and see what's going on. So how do you take a very complicated equation and get a sense of what the key features are? That's something I'm going to emphasize time and time again. Can you get a sense of the main term? Can you get a sense of the behavior? Can you get a sense of what's happening? If I change this parameter, what will happen? I really want you to be able to do that with equations. A lot of the stuff is going to come from sports. I apologize for those of you who are not sports fans. If I do it too much, just let me know. But there's a lot of great things you can discuss with sports. All right, so types of problems we'll look at. A lot of this is going to be a function of what you want to study. And so if there's a subject that you particularly like, let me know. One year somebody wanted me to talk about food preparation. Fine. If you let me know, preferably in advance, it gives me a better chance of making a good connection. But if there's something you want to see, how does probability apply to blah? I will try to work that into this class. A lot of stuff comes in physics, chemistry. We will probably talk a little bit about random matrix theory. It's a wonderful topic that allows you to model a bunch of very different phenomena using the same type of mathematics. How many of you have taken a physics class? You've done anything with gravity. Gravity is a 1 over r squared force. Electricity and magnetism. Electricity is a 1 over r squared force, at least if we're not doing things relativistically. Well, if they're both 1 over r squared forces, this suggests that a lot of the analysis we do in one subject can just be transferred over to the other. And that's what you want to be able to do in mathematics. You want to apply tools from one area to another. We will do a little bit on economics, a little bit on portfolio theory. If people want to do a little bit more, let me know. I'm happy to do that. You can also do a project for this class, and I will decrease how much the other sectors count for your grade. So if there's something that you really want to dive into, by all means, take control of your education. If you want to learn about the Black-Scholes equation, great thing to study. And I'm happy to have you doing something like that rather than doing some standard homework problems. I will do financing. I've done a lot of work in applied mathematics. One of my favorites is I worked on a problem for the movie industry. So imagine you own a series of movie theaters. What is your goal? Yes?
Get them as full as possible for every movie.
Okay, what are you majoring in?
Stats.
Okay, then that's a fine answer for someone who's stats, but that's not the right answer. It's not to get as many people as possible. Maximize profit. Okay? How many people here are studying economics? So almost as a default, the goal is to make as much money as possible. All right? This is why I'm a math professor, because that's not my goal. My goal is to work on problems that I find fun and enjoyable. And in fact, as an aside, I was complaining about the discrepancy in salaries between mathematicians and economists to an econ colleague of mine a few years ago. And I said, I can go to Wall Street just as easily as you, more so in fact, and I can do more. And they go, but Steve, they know you won't do it. And yeah, you got me. And so what we actually need is we need a bunch of mathematicians to actually stop teaching mathematics to make the threat credible. But we just love this too much, so it doesn't really happen. So whenever I ask you a business problem, almost surely the answer is to make money. Now, if I ask you, how do we make money as a movie theater? One of the ways to do that is to schedule the movies as well as possible. Do you think ticket sales is where movies make their money, or movie theaters make their money? Where do they make their money? From the food. There's a lot of movie theaters that will have admission will be $1. And they'll show old movies because they want to make the popcorn sales. They want to make the soda sales. And so it becomes a really interesting question. You want to estimate what is the demand. How many people will want to see this movie versus that movie? How much money would I make? Do you want to show a movie that a lot of, say, teenage college couples will go to, or a lot of old retired couples will go to? Old retired couples, why? So old retired couples have more time, maybe you'll have a higher turnout. Why might you, yes? More disposable income. So I teach classes on Legos, and Lego had a difficulty several years ago. They came up with Lego Mindstorm, and they were upset at first that people were hacking into the operating system. And then they realized, wait a minute, these are adults who don't have to get permission from mommy and daddy to buy stuff, and they can buy a lot of stuff. We should be happy that they want to buy our product. And so Lego, they had to really think, do they want to stop being exclusively for kids and also have an adult market? So one is the adults have more disposable income. But there is a reason why you might want to target, say, high school, college kids. Yes?
More likely to buy food at the theater?
More likely to buy food at the theater. And so, especially when you consider how the deals are arranged, when you screen a movie, you have to give a certain percent of the sales of the tickets to whoever owns the movie. And if it's, say, George Lucas or Disney, they may be able to negotiate a very large percentage, but you don't share the concession sales. And so you have to decide, where's your best way? What do I expect the probability of having this many people be? What do I expect the probability will be that they will buy something? You know, we have these all over the place. Another big example is in cryptography. We may talk about that. In previous years, I've actually run lunch classes on how to play bridge. It's a wonderful card game. If anybody's interested in learning how to play bridge or knows how to play bridge and wants to get some games going, let me know. Big thing in this subject is trying to estimate the split of cards. How likely is it that the cards that I don't have fall this many in this hand and that many in that hand? All mathematics, all probabilities. Okay, so my applied experience, I've talked a little bit about this. I've done work in marketing. I've done work on movie scheduling. I've worked for the Internal Revenue Service. I will talk about Benford's law of digit bias later in the semester. It's one of my favorite topics. I'm advising at least one thesis on it right now. I just came back from a wonderful day at Duke University. I gave 2 talks, one to the undergraduates on Benford's law of digit bias and applications of this with the IRS for detecting tax fraud. Years ago, I gave a version of this talk at the Boston headquarters of the IRS, and they gave me some parting gifts, including an Al Capone bobblehead. When I came back, or when I was flying back, the Al Capone bobblehead set off the security alarms, and it was just wonderful seeing all these agents coming down, taking him out, and frisking the Al Capone bobblehead. I would have taken a picture, but I also set off the security alarms, and so I no longer had my phone at the time. But it's nice, 60, 70 years after his death, they are still looking at Al Capone. What did they get Al Capone for? Yes? Tax evasion. Killing people, that's one thing. But not paying your taxes, we've got standards in our country. Okay? So how do you discover stuff like this? What is the probability that someone is cheating on their tax? Oh, sorry. I won't write down the probability that someone is cheating on their taxes, but what is the probability that someone is cheating on their taxes and you can prove that they're cheating on their taxes? If you have finite resources, how do you decide which companies or individuals to investigate? These are great applications of probability. I've actually done a lot of work in sabermetrics. This is applying mathematics and statistics to sports like baseball and to a lesser extent to basketball, football, hockey. Why do you think we apply it more to baseball than other subjects, than other sports?
It's one-on-one.
Yeah, one is you have this beautiful one-on-one, pitcher versus batter, how well the fielder does. When you are football, I remember years ago, Michigan was playing, I think it was USC in one of the bowl games. And the Michigan offensive line may have been made out of paper for the amount of time they gave the quarterback. Doesn't matter how good the quarterback is, doesn't matter how good the receivers are. If you can't give even 2 or 3 seconds of protection to the quarterback, you're not doing much. And so there's so many different parts that are all going on at the same time. If you want to estimate how good is an individual on the offensive line, well, it depends who else is with them. So one reason why we love baseball is it's much easier to calculate what's going on. There's another reason why baseball is better than these sports. A lot of games. There's more than 10 times as many games in baseball in a regular season than there are in football. So you have a wealth more of data points. So I will talk a lot about baseball at various times in the semester. I've actually worked with, as I've said, general managers and major league franchise teams. If anybody's interested, I actually do have a project right now for an MLB franchise. I don't want to go into detail as this is being recorded. Are there any Yankee fans here? It is not a protected category. Any Red Sox fans here? Excellent. So I will try to be balanced between the 2 different sports teams and the 2 different sports cities. I will talk a little bit about the New York Giants in a positive light later today. This is in honor of a former student of mine, Michael Stone. He's actually one of the people at the company I've emailed you about. And he is my opposite in sports. He likes the Giants, I like the Patriots. He likes the Yankees, I like the Red Sox. He likes the Lakers, I like the Celtics. And so to try to be balanced so that I can be unbalanced at other times, I will say nice things about the New York Giants today as a way to demonstrate why you need to learn probability. Course mechanics, probably the most important slide, the most enjoyable. We're going to move at a fast pace. I'm not going to assume you've done more than linear algebra, but I will assume you read the book before class other than today. This does not mean if I drop dead, you can give the lecture. But it means you have some familiarity of what the lecture is going to be about. If the topic of the day is Stirling's formula, what do you think you should know for the day? What Stirling's formula is. What are the key terms? This doesn't mean you necessarily have to know the proof, but if you're trying to understand the new terms as it comes in, it's going to be very hard. So skim the material before class. And I've also posted a brief summary of all the different sections of the book, just like a highlights. So you have some idea of what the lecture is going to be on. For the most part, we're going to go in order. We will move at a fast pace. 5% of the grade is going to be class participation, I think, or... well, here. I'll double check this to make sure it's right. There will be 2 midterms and a final. The final will be during the semester. Unless you tell me otherwise, I will drop your lowest midterm score. Okay? If you want me to count your lower midterm score as well, let me know. There are sometimes strange situations where you might want a bad grade in a course. I don't know of any of these at Williams, but at Brown, if you got a grade below a certain amount, you could have the class removed from your transcript, so you would actually want to fail certain classes. I don't think that's the case here, so I'm going to assume that everybody wants me to drop their lowest midterm score and improve their averages. You are not competing with each other for grades. If everybody gets an A, I will contact the registrar. If everybody gets an E, I will also contact the registrar. I'm not grading on a curve. I strongly encourage you work together, form study groups, discuss the material with each other. Prereqs are Calc 3, basic combinatorics and set theory, things you've already seen, and linear algebra. In terms of office hours, I'm going to choose office hours once you choose what your courses are and what your schedules are. I know a lot of people's schedules are still in flux. I don't want to finalize when my things are while you're still moving. If I'm in my office, it's office hours. Just knock on the door. My schedule is also posted online, and I'll give you access to that. You can also contact me either directly or anonymously if you have a concern either about this class or about something else. The email is eefsmath@gmail.com. The password right now is 1793. Somebody a few months ago changed the password, so depending on where you go online, it might have a different password. Please don't change the Gmail password. Okay, I've tried to set it up now so that you can't do that. Okay. Hopefully, it may not have recorded the first part of the lecture. Oh well. So, the more you bet on the Giants, the less likely you are to make money. Right? Yes.
So when you said that statement, you said the less likely you are to make money. Did you say the less...
I'm sorry, to make a big amount of money. Your expected return is going to get smaller and smaller and smaller. Until when you put down so much money on the Giants that you would expect to make $0. And in fact, if you put down, say, $10 million on the Giants, you would expect to lose big. Right? All right. So now by hedging, you can guarantee some amount of winnings. So now, let's say we bet a side bet on the Giants. And now what we want to do is we want to look at how much money we make as a function of the different probabilities. So we'll fix a probability now just so it's a one flat picture. I'll say the probability the Patriots win is 80%. And we'll say every dollar you bet on the Giants, if the Giants win, you get $3 back. And what I'm going to do is I'm going to plot the minimum amount that you would win. So if you have a small amount of money bet on the Giants, your minimum amount of return is going to be when the Giants win. If you have a large amount of money bet on the Giants, your minimum amount is going to be when the Patriots win. And you can calculate, what is your best worst case scenario. And here the best worst case scenario looks like maybe around $160,000. And it guarantees you winning almost $350,000. Is $350,000 as good as $500,000? No. Is it better than zero? Yes. Which would you rather have? I mean, a lot of it depends on how likely. If the odds are only 1 in a million that the Giants win, probably at that point you let it ride and you just bet on the Patriots. If, however, there's a significant chance, maybe a 10-20% chance that the Giants win, getting $350,000 is enough to change your life. The marginal utility of that extra $150,000 is not that much, especially when you consider taxes. So in a situation like this, it's much better to put a side bet. And then figuring out exactly how much you want to bet, this is all probability. All right, so here is some simple code in Mathematica to do this problem. All right, so I don't really care, as I said, what programming language you use. I use Mathematica because that's what I learned when I was in college. That's what we used for physics labs. I've also programmed in C, Pascal, Logo, Basic, Fortran, whatever language you want to use, I should be able to help you at least structurally. In terms of the mechanics, depending on what language you use, I may not be able to help you with the actual syntax. But I want you to be able to program. So everyone is going to have to program some problems. Partly this is because I want you to have a useful skill. And time after time, alumni who have taken my classes have told me one of the most useful things they've had in their college career is being kicked and forced to learn how to code. A lot of times we have very complicated problems, and we can approximate the answers by running these numerical calculations. This is considered by many to be the greatest insight in 20th century mathematics. The idea that you have a really complicated problem, you can estimate the answer by just running millions and millions of simulations. And this is called Monte Carlo. We will talk about this at great length. Mathematica has a lot of wonderful features. I'm not going to go through them right now, but you can put this thing called manipulate, and it will give you sliding bars, and you can see how things will change if you change the payoff, if you change the probability of things, of the Patriots winning. And so you can run all these simulations, yes?
What's the x-axis?
So the x-axis on this graph is, it's sadly cutting off on the screen, which I'm not quite sure why. The x-axis is, I believe, how much money you're betting on the Giants. And the y-axis is how much money you make. And so not surprisingly, since we expect the Patriots to win, the more money we're betting on the Giants, the more trouble we have. Okay. So I will end with at least the picture of the Patriots winning a recent Super Bowl. Anybody know why the Patriots won the Super Bowl? So this is the Super Bowl against the Seattle Seahawks. So there's a lot of debate as to should the Seattle Seahawks have run. And there's a lot of debate about did the Seattle Seahawks mismanage the clock. I actually don't think it was a bad idea to pass. I think it was a bad idea for the Seahawks to pass into traffic up the middle. You know, at the end of the first half, Seattle went for the touchdown and not the field goal. They did a pass towards the corners. And if you pass towards the corners, it's much harder to intercept. But if you look at the probability of rushing and getting the touchdown, their star rusher was not as good as getting touchdowns as people thought. That when you have to get that 1 or 2 yards and the defense knows the run is coming, the defense is prepared. If you do a different play, you have a chance of catching people by surprise. And so this all comes down to probabilities. The Patriots also suspected that this might be happening. And in fact, in practice, Malcolm Butler, who intercepts the ball, he was burned by the Patriots when they practiced this play. They practiced this play once. And so he was prepared. So as much as possible, you want to be prepared for what comes. This goes back to what I said about being at the Institute and finding out I have to now say a few words. You don't know when that opportunity is going to happen. So you want to prepare. Now the difficulty, of course, is there's a lot of things you can prepare for. And you have to decide which ones do you want to prepare for. There are some things that are really stupid and are probably not worth preparing for, such as they hike the ball to the quarterback who starts running backwards. Fast and far. Okay, we're not going to really worry about preparing for that. If they want to do that, by all means, go for it. So you have to decide which is going to be the greatest yield. Okay, so this is the general mechanics lecture. On Monday, we're going to start going through Chapter 1 in great detail. We will do the birthday problem. Please make sure you bring an ID to class. We've still got a few minutes left, so any general questions right now? Yes?
I'm just wondering, like, how much in advance do we expect you to update the textbook readings and homework? Like, I know there's 2 weeks in advance.
Right. For the most part, I'll probably be at least a week in advance. I want to see how fast the class is going. And so if you know that you're going to be exceptionally busy in the near future and you want me to update it a little bit faster, just let me know. And I have strong suspicions as to what things are going to be. But sometimes due to travel or guests or various things, we're going to have some guest speakers coming in that will tweak things just a little bit. I will also try to have the homework not covering everything up to, say, the Friday lecture and then homework is due on Monday. I'll try to have the material covered a little bit earlier so that you can start working on problems. So as soon as you can, I urge you to start working on the problems and getting things done. Yes?
Lectures, are they used on Glow?
No. So I am primitive. I don't use Glow or anything like this. And this way, whenever OIT sends an email that we are now changing from Glow to Glow 2 or Glow Prime, I just hit delete. So I actually write my own HTML code and I use an interface. My websites, they're described as having a 90s flavor because I'm using 90s technology. The information is there. All the lectures are posted on YouTube, and I'll give you the links. So it may have misrecorded today's lecture, so I will give you last year's.
Will it probably be just after class?
Right. So it takes somewhere between 5 and 6 minutes to transfer the files from the iPad to the computer, and then it takes potentially 1 to 2 hours to upload and have YouTube process it. So typically by the end of the day, the lecture will be available. Any other mechanics questions? Yes?
So if you don't know mathematics, would you recommend learning it for this?
I think so.
Okay.
If you're going to be a stats major, I would recommend you learn R.
Okay.
So for the stats classes, they love R.
So if you already know R.
If you already know R, that's fine. Mathematica, I think, is a bit friendlier. I think it has a better graphics interface. I think it does a better job of having a bunch of predefined functions that number theorists care about, because that's, in some sense, who all the audience is for. People who really want to practice programming, how many of you know about the Project Euler problems? So if anybody wants to, I'm happy to organize discussions around Project Euler problems. These are challenges in both mathematics and CS. You want to solve a problem fast and efficiently. These problems are often trivial to do by brute force, but if you had an entire universe where every subatomic particle was a supercomputer devoted exclusively to you, running since the dawn of time, it would not be enough to dent the problem by brute force. And so these problems are designed to both push you mathematically and push you in terms of programming. So how can you program things quickly? I'll end with one comment. How many of you have done Sudokus? Okay, so here's one of my favorite examples. In Sudoku, in each column you have to have the numbers 1 through 9, in each row 1 through 9, and each block 1 through 9. So if you want to check and see that a column is valid, what do you have to do to make sure the column is valid? There's only one 1, there's only one 2, there's only one 3. How many checks is that? 10. Not 10. 9. There's a way to do it in one check. Does it matter that I use the numbers 1 through 9? Could I use letters A, B, and C? Could I use smiley face? Could I use emojis? Yes. People would look at me funny, but I could do that. Let's use the numbers 1, 10, 100, 1,000, ... All I have to do now is check and see, is the sum of the column 111,000,000, 111,000, 111? If so, I have one of everything. So there's no real difference, and theoretically it doesn't matter. Programmatically, huge difference. So that's one of the things I want you to get out of this class. Okay, so I think there's actually another class that's forced to come down here. I feel sorry for them.